What if you could perform calculations 1,000,000 times faster than any supercomputer in existence today? Welcome to the world of quantum computing. Dive with us into a realm where the lines between science fiction and reality blur. Quantum computing, a concept that has left many awestruck and bewildered, is not just a fanciful idea. It's a revolutionary technology that's set to redefine the boundaries of computation as we know it. Unlike classical computing, which relies on bits that exist in a state of 0 or 1, quantum computing operates on a different plane. It introduces us to the concept of qubits or quantum bits, the basic units of information in a quantum computer. But here's where things get truly mind-bending. Qubits can exist in a state of 0 and 1 simultaneously, thanks to a quantum quirk known as superposition. Imagine having a coin that, when flipped, doesn't just land on heads or tails but can balance on its edge, embodying both states at once. That's the quantum leap we're talking about. This ability for multiple states to coexist allows quantum computers to process a vast number of possibilities all at once, enabling massively parallel computation. It's like having 1,000,000 supercomputers working together simultaneously, all within a single quantum machine. And it doesn't stop at superposition. Quantum computing also utilizes another quantum phenomenon known as entanglement, where qubits become inextricably linked, no matter how far apart they are. Change the state of one, and the other changes instantly. This opens up possibilities for complex computations and data handling that classical computers can only dream of. But don't be too quick to bid your traditional computer farewell. Quantum computing isn't set to replace classical computing. Rather, it promises to take us beyond its limitations, into uncharted territories where we can solve problems and perform calculations that were previously deemed impossible. So quantum computing isn't just about speed, it's about a whole new way of thinking about information processing. What makes quantum computing so powerful? It all comes down to these strange little things called qubits. To truly understand the might of quantum computing, we first need to grasp the concept of a qubit, or a quantum bit. Unlike classical bits, which are confined to a state of either 0 or 1, qubits can inhabit both states simultaneously thanks to a peculiar quantum principle known as superposition. Picture it like this. If a classical bit was a coin that had to be either heads or tails, a qubit would be a coin spinning on its edge, simultaneously in a state of heads and tails. However, in the quantum world, things get even more fascinating. Enter entanglement, a phenomenon that links qubits in such a way that the state of one instantly influences the state of the other, no matter the distance in between. Imagine having a pair of dice, and no matter how far apart you roll them, they always land on the same number. That's entanglement in the quantum realm. Now, why does this matter for computing? Well, these unique properties of qubits allow quantum computers to process a gargantuan number of possibilities at once. Where a classical computer would have to trudge through potential solutions one at a time, a quantum computer can explore all paths simultaneously. This is akin to being able to navigate an enormous labyrinth in an instant, instead of exploring each twist and turn sequentially. The implications of this are immense. Tasks that would take a classical computer longer than the age of the universe to solve could potentially be completed by a quantum computer in mere seconds. This is not just a step up from classical computing, it's a giant leap, a paradigm shift. And yet this is just scratching the surface of what quantum computing can achieve. As we continue to delve deeper into the quantum realm, who knows what other extraordinary capabilities we'll uncover. Qubits, through their unique properties, hold the key to the extraordinary potential of quantum computing. How does a quantum computer actually solve problems? It's all about quantum algorithms. Quantum algorithms are the set of instructions that guide the behavior of qubits, the basic units of information in quantum computing. To understand quantum algorithms, let's talk about two key examples, Shor's algorithm and Grover's algorithm. Shor's algorithm, named after mathematician Peter Shor, is designed for factorizing large numbers, a complex task for classical computers. But in the quantum realm, Shor's algorithm can accomplish this with astounding efficiency. It's this kind of power that could one day crack encryption systems, which often rely on the difficulty of factorization to keep data secure. Then there's Grover's algorithm, developed by Love Grover. This algorithm is a search tool, but not in the way you might think. It's not for browsing the web, but for searching through unsorted databases or solving complex mathematical problems. Grover's algorithm can perform this search quadratically faster than any classical algorithm. Imagine a library of millions of books, and you're looking for one specific page in one specific book. Grover's algorithm could find it much faster than a classical computer. These quantum algorithms are just the tip of the iceberg, but they help illustrate the concept of quantum supremacy. This is the point where quantum computers outperform classical computers in certain tasks. As of now, we're still in a race to achieve true quantum supremacy. In 2019, Google claimed to reach this milestone. Yet, many in the scientific community argue that we're still at the dawn of this new technological era, with the true potential of quantum computing yet to be fully realized. The journey to quantum supremacy isn't about replacing our classical computers, but about unlocking new possibilities. It's about solving problems that were previously deemed unsolvable, about pushing the boundaries of what we thought was possible. While we're still in the early days of quantum computing, the potential for quantum supremacy is a game changer. It's a revolution in the making, reshaping the landscape of technology and promising a future where the impossible becomes possible. Quantum computing isn't just an interesting theory, it has profound implications for our world. Let's take a closer look at how this revolutionary technology could reshape our future. Picture this: cryptography, the science of encoding and decoding information, could be completely overhauled by quantum computing. Today's most secure encryption methods might become easily crackable, which could either be a potential threat or a powerful tool, depending on who wields it. On the flip side, quantum computing could also give rise to unbreakable encryption systems, ushering in a new era of cybersecurity. Now, imagine the world of artificial intelligence. It's already transforming industries and our everyday lives. But with quantum computing, AI could be supercharged. Complex problems that take years to solve could potentially be handled in mere seconds. Machine learning could become more efficient, leading to breakthroughs in everything from autonomous vehicles to personalized medicine. Speaking of medicine, let's delve into drug discovery. It's a field that requires the exploration of vast molecular landscapes, a task that's daunting for even the most powerful of today's computers. But quantum computers, with their ability to process immense amounts of data simultaneously, could revolutionize this process. They could help us discover new drugs and understand diseases in ways we can't even fathom today. But like any powerful tool, quantum computing comes with challenges. There are technical hurdles, of course, like creating stable quantum bits or qubits. There are also ethical considerations. How do we ensure that such powerful technology is used responsibly? How do we safeguard against misuse? These are questions we must grapple with as we venture further into the quantum realm. As we stand on the brink of the quantum revolution, we are limited only by our imagination. The implications of quantum computing are vast and varied, and we're only just beginning to scratch the surface. It's an exciting, albeit complex frontier we're stepping into, and it's bound to change the face of technology as we know it. So, what does the future hold for quantum computing? As we gaze into the crystal ball of quantum computing, we see a future shimmering with potential. Quantum computing, a concept that was once purely theoretical, is inching closer to reality, with numerous tech giants working tirelessly to develop viable quantum computers. Picture a world where quantum computers are as commonplace as the smartphones we carry in our pockets today. These quantum machines will have the power to solve complex problems that today's most advanced supercomputers can't even scratch the surface of. And we're not just talking about crunching numbers faster. We're talking about revolutionizing fields like cryptography, artificial intelligence, and drug discovery, to name just a few. But when exactly will this quantum future arrive? That's the million-dollar question. Some experts believe we could see quantum supremacy, the point where quantum computers outperform classical computers, in the next decade. Others are more conservative, suggesting that we're still several decades away. Regardless of the timeline, one thing is certain. Major tech companies are playing a pivotal role in advancing quantum computing technology. Companies like Google, IBM, and Microsoft are investing heavily in quantum research, racing to be the first to achieve quantum supremacy. Google, for instance, has already claimed to reach a milestone in quantum computing. In 2019, it announced that its quantum computer performed a calculation in just over 3 minutes that would take the world's fastest supercomputer thousands of years. IBM, on the other hand, has a quantum computer accessible to the public via the cloud, allowing researchers and enthusiasts alike to experiment with quantum computing. The future of quantum computing is both exciting and unpredictable. It's a vast, largely unexplored territory that holds the promise of immense computational power and transformative technological advancements. The quantum computing revolution is just beginning. It's a thrilling time to be alive as we witness the dawn of a new era in technology.